Hello everyone. So today I am going to discuss Codeforce's round 783 problem A, B and C. So let's start with the first problem, which is problem A. So what this problem says is that it is you are given a grid of size n and n cross m, rows and columns number from 1 to n and 1 to m. All right. The intersection of A throw and B throw is denoted by AB. Good. Initially, you are standing at the top left corner, that is 1 1, and your goal is to reach the bottom right corner, that is nm. You can move in four directions. All right, a to b to up to a minus 1b means left, sorry, it means upside from this index. This is down, this is left, and this is right. All right, so but you cannot move in the same direction in two consecutive moves. Okay, so you have, okay, and you cannot leave the grid. What is the minimum number of moves to reach n and m? Input is given, there are number of test cases, n and m will be given for each test case, and you have to print a single integer -1 if it is impossible to reach nm under the given condition, otherwise minimum number of moves. Okay, so now let's look at the solution. So basically, if let's say this is a grid, right? So if this is a grid, I am standing at here and my goal is to reach here. So to reach from one index to another index, the minimum number of moves that I have to do is, like, so at least I have, if let's say I want to reach let's say this index, right? So at least I have to move to this much direction in vertical direction and this much distance in horizontal direction. That is must, otherwise I can't reach here, right? So what I will first do is, we'll first go from this point to a point greedily. So basically, let's you can see that, give me a second. So you can see that the number of rows here is 1 2 3 4 5 6 and 7. So there are 7 rows and there are 5 columns, right? So you can take this as a, so first of all, so that, as I said, that we have to at least move horizontally or vertically this distance, but in this question it is not possible to do that because we cannot make two consecutive moves. So if I have moved right once, then I cannot make another move to the right. So either I have to move upwards or I have to move downwards, right? So what I'll do is, in that case, I'll go greedily. Just a second. So I'll go greedily from this point to the rightmost point and the downmost point possible. First of all, I'll do that. So first, what I can do is, I'll go down, right, down, right, down, right, down, and right, right. So this is the point where I can reach with the minimum number of steps right now with a greedy approach, right? Or else, what I can do is, I can go in this direction, this type also, the right, down, right, down, right, down, and right, down. All right. Now see, if so my goal is to reach here. So if I want to move this in from this index to this index, if I have come from this black path, okay, through this black path, then the last move I have done to reach this point is right. So I can move in down direction to reach this point. On the other hand, if I am reaching this point through this blue path, then I cannot make this down move because I have already made a down move. So I have to go to left and then I have to go to down and then I have to go to right. So I will not choose right path. Okay. So let's say now I have moved here in this point. So what I will do is, I have to move from this index to this index, but I cannot directly move downwards. So what I will do is, I will go one step up, then one step down, sorry, one step left, then one step down, and then one step rightwards, and I will reach to the end index. So basically, as you can see that this first part requires how many steps? This requires 2 into n or x minus 1 steps, where x is the minimum of n cross n comma n, right? So basically this will be a square matrix of whatever is the minimum value between the number of rows and number of columns. So that much distance I can move by via 2 cross n minus 1 moves. And after that what will happen is, after that whatever is the number of moves, number of boxes or number of cells that I am far from the end index, so I have to move like this. I have to go one, like I have to take one move, then to reach the next index I have to take three moves, right? So if let's say this is the third move, after taking three moves I am here. So let's say this matrix has another row. So from moving here to here I can take only one move, right? So then I'll take one move, then I'll take three move, right? So then I'll take three move, then I'll take one move, and then this will continue. All right. So basically this will be the number of moves, and plus this will be the number of moves based on how many number of rows I have. So if I have, let's say, even number of rows, so that will be 1 and 3, then 1 and 3, like this it will continue. So I'll find, so first I'll calculate this, then I'll find the remaining number of nodes. So remaining number of rows or remaining number of columns, whatever it is there. Once I get that remaining number, I'll check if that is even or odd. Based on that I'll take a decision, right? So let me just go through the code, then you'll understand it better. So as you can see here that yeah, so I've taken in a name. If in a name is 1, means there is only one cell, then the answer will be 0. Otherwise so basically C has the count of number of moves. So first I'll take 2 into x minus 1, x is minimum of nm, and then I'll calculate the remaining cells that I have to traverse. Okay, so that will be max minus mean of n comma n. Okay, so now if minimum of nm is 1, means there is only one row or one column, and accordingly the number of columns and rows is greater than or equal to 3, then it is not possible. So what it is saying is that, let's say that there is a matrix given like this. So at max I can move from here to here, then I cannot move, right? Similarly same thing will happen for a this kind of a matrix. I can move from here to here, but then I can't move. So that case is taken care here. Then after that I'll just check that if the remaining r is even, then the c r by 2 will be added to c. So there will be r by 2 once and r by 2 threes, right? So as you can see here, let me just take you here. So the sequence that we have had was 1 3 1 3 1 3. So if there is even number of moves, then either I will have these, or I will have these, or I will have this, right? So there will be same number of ones and same number of twos, same number of threes. And if there is odd, the r is odd, then either I will have this 1, or I will have this 1 3 1, or I will have 1 3 1 3 1, like this, right? So for odd number of remaining cells, number of ones will be one more than the number of threes. So you can see here, if r is even, then the number of threes is r by 2 only, but the number of ones is r by 2 plus 1 more, and then you can basically print the C. So we will get the answer. So this was problem A. Now let me move to problem B. Alright, so what problem B states? So problem B is saying that there are m chairs that are arranged in a circle sequentially. The chairs are numbered from 0 to m minus 1. Okay, there are m chairs. There are n people who want to sit in these chairs. The ith of them wants to sit at least ai empty chairs, both on this right and left side. Okay, decide if it is possible to sit down for all of them under the given limitations. Okay, so let me explain you what this question says. Okay, so what this question says is that you have a circular round table. Alright, you have a circular round table, and there are some persons who are sitting here in this round table. So let's say this is from 1 2 3 dot 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 dot. Let's say this is n, this is n minus 1, and so on. So now each person wants a particular amount of space to its left and to its right to be left empty. Okay, so we have to basically tell that whether it's possible to make an arrangement for all the persons that is given to us. Okay, so basically for this what we can do, right? Let's say first of all where these persons are sitting does not matter to us, right? So let's say if I make one seat one step to the right, then I can make all these persons to sit one step to the right and the sequence will remain same, right? So with where I am placing these persons does not matter. What matters is how much space this person needs. That is what matters. If the total space that all of them needs, if the minimum total space that all of them needs is less than or equal to whatever the seat that is given to us, then we can say that we can make an arrangement. Otherwise we will not be able to make an arrangement. So let's say let's say I am sorting the array that is given to us, which is a array, means that which has the persons like how many space the person needs, right, to seat. So let's say I am sorting the given a array. So basically a n minus 1 is the maximum space that n minus 1th person needs. So now let's say okay, let me just draw another circle. Let's say this is the table that we are given. Okay, and I have placed, let's say, a n minus 1 here, and we know that this is the space that it needs to be left empty. So now, because this is the maximum space, so whatever will be the value of a n minus 2, that will be less than a n minus 1. Just give me a second. Yeah, that will be less than a n minus 1, which means that if so what I can do is I can place a n minus 1 n minus 2 here. And why I am placing n minus 2 here? Why I am placing a n minus 2 here? Because the left space that a n minus 2 needs are overlapping with the right space of a n minus 1. So I am basically trying to optimize the amount of space that is needed. So I am trying to reduce this space, the extra space that is left empty, right? And then obviously I will have a right space that I can't really make up. So in the similar fashion I can go with a n minus 3. So I can place a n minus 3 here. So there will be a certain place that will be covered here, and there will be a certain place on the right, and like that I can continue. So in this way I can optimally use the number of chairs, because I am overlapping as much as I can, right? So that I need the minimum amount of space. So now let's look at the code that I have written. So you can see that I have taken the input of AI, then I have sorted it, then I have taken a variable for required like how many minimum seats are required, and then I am traversing from the largest element to the smallest element, and I am saying that the required amount of space is a of I plus 1. So you can see here that for any index, alright, so let's say for I am considering for a n minus 2. So for this index how many space I need to add? The left space is already covered while I was calculating a n minus 1, that is overlapped, so I don't need that. So the space the chair that this a n minus 2 needs, that is 1, plus this a n minus 2 value to the right is not overlapped, that I have to take, so that will be a n minus 2. So for every person I need 1 plus a of I. This is the space that I need, so that I have added, and at the end what I have added is I did a required plus, because the last element, that is the 0th element, which has the smallest amount of space that is needed, for that I have added one space, and I have added a n minus 1. Why I have added a n minus 1? Because we have not taken care of this left part. So for a n minus 1 as well I have taken this space, this one, and this space only, right space in the loop, right? So I have ignored this left space, So that's why after the loop finishes, I am taking this space as well. And now I am checking if the required space, minimum space, is greater than m, then obviously it's not possible, otherwise it is possible. So that is it. Give me a second. Okay, now let's move to the C problem. Alright, so what it says is, you are given an array A consisting of n positive integers and an array B with length n. Initially bi is 0. Okay, so all the elements of B is 0. In one move, you can choose an integer and add ai to B or subtract ai to bi. What is the minimum number of moves needed to make B increasing? That is, every element is strictly greater than every element before it. N is given that less than equal to 500. This is 5000. This is very interesting. It means that the solution may not be like maybe go up till order of n square. All right. Let's just okay. Now let's discuss the sorry, solution here. Alright, so what the question says is that you are given an array B. You are given an array B which has 0 inside it. Okay. And then you are given an array A. Okay. So this is B. And you are given an array A which has some values here. Let's say V1, V2, some values here are given. So now for any index, okay, for any index, you can either add V1 or you can subtract V1 as many times as you can. Alright, and each operation that you do, either addition or subtraction, this will be considered as a move. So now you have to find the minimum move so that this B becomes increasing, strictly increasing. Remember this. So basically B has to become strictly increasing, right? So first of all, obviously, if I, let's say for any index, if I am adding the value, then I'll definitely not subtract the value in the future, because then I am basically using two moves to get to the same state, right? So that is not optimal. So it simply means that for any index, either I'll add the values of from A in some x amount of time, let's say, or I'll subtract the values of A. Either of these two I'll do, right? So it means that in the resultant array that I'll have at B, the elements will either, some elements will be negative or and some elements will be positive, right? That is for sure, that will be there in B. Why? Because all the elements in B are positive. You can see here that all the elements of all the elements of A are positive. So if I subtract them from 0, then it will always be negative. If I add them, then it will be positive. So because there will be some elements which are negative and there will be some elements which are positive, so it simply means that in the resultant array of B, all the negative elements will be to the left of the positive elements. So basically the resultant array B, if this is the resultant array B, this can be divided into two parts, where the left part all the elements are negative and the right parts are positive. And because it has to be increasing, obviously for this positive it has to increase, and for this negative it has to increase, like the values has to increase, but the absolute values, right? Because these are negative, so let's say -5, -6, like that. So the absolute values has to increase in this direction. If we get the absolute values increasing, then because we are doing negative, so we'll get the negative values as increasing from left to right. So that is what we have to do. We have to find the pivot, we have to find the index where the left values are negative and the right values are positive, in such a way that this is continuously increasing. So what we will do is, we'll go to all the possible pivots like this, all the possible dividends that can divide this array, and I'll check that if I have to make this array increasing to the right side with the positive values, then how many operations I need, and to the left, if I have to do to the left, then how many operations I need, and I will find the minimum out of all these operations. So you can see the solution here. All right, so the cm, the cm is the current, current count, you can say. This is the current count, and this answer contains the ultimate answer. So now I'm going from I equal to 0 to I equal to n I plus plus, right? So these are the pivots. So then so basically, so let's say I am at I'm at ith index, right? So I can be left as 0. I will not add or subtract anything at ith position, and then all the position to the right will be positive and all the position to the left are going to be negative. Okay, so we'll start j from I minus 2. Will take a counter c, and pc is the previous counter. All right, and then I'll go to the left, and I'll just see the increase, like how much I have to increase. So to find the increasing element, what you need to do is, let's say this is an element, right? This is an element that I have after adding the a to the b. Obviously I'll add it once, because the more I'll add it here, to find the increasing sequence to the left I have to add more elements, so that will just unnecessarily increase the number of moves. So whatever is here I'll add once, then I'll just go to this element, which is a of j minus which is a of j minus 1, and then I'll check for this element, that whatever is this element, how many times I have to need the value here, so that it is more than this element. So you can see here that for jth index I am checking for j plus 1th index. This is the j plus 1th index. This, let's say this is jth index and this is j plus 1. So I'm checking the j plus 1th index, that how many times, like pc is the previous count, so how many times I have added the element at j plus 1. So if it is less than equal to this thing, then I'll just calculate that how many times I have to add the a of j to the b, so that this becomes more than a of j plus 1 into pc. So that is I am calculating, and then I am adding that to the cm. All right, and okay, then I am updating the pc, because for the next iteration pc will become the currency and c will become 1, g minus minus. Same thing I am doing for the right side. Okay, and why I am taking, by the way, I minus 2, because I know that this element I am going to add only once, so I don't have to calculate how many times or see or count of this element. That's why I am starting directly from I minus 2 here. Similarly for I plus 1 also, I am not calculating for I plus 1, because I know I will only add once, so I am starting directly from I plus 2, and I am doing the same thing here. You can check. All right, so I am getting, then I am getting the minimum answer, and then I am adding uh, n plus n minus 1, because here I have already taken it that I am adding these a elements are already added here. So to add those elements I have to at least take n minus 1 operations, and then you can, so that's how we will get the answer. So thank you, that was it. Thank you for watching this video. If you have any other suggestion, please let me know in the comment section.